Okay, in this video, we're going to learn what we need to show work-wise for binomial, and we're going to work through some basic binomial problems. We're going to move fairly rapidly and also go through the calculator problems. At the top of the page, I have my version of the binomial distribution formula, but really we probably should be looking at n choose x, p to the x, and then 1 minus p to the n minus x. That's what's on your formula chart, and you'll always have that available to you either in class or on the AP exam. Okay, because that's going to be important to show your work in that form. Please don't forget that n choose x means this, but the calculator is going to do that for you automatically. So our first scenario, what is the probability of having a defect item is 0.3 given a box of 5 light bulbs. So basically they're telling us the probability is 0.3 and they're telling us, hey, and we can look at that and go, you know what? That is a constant probability. It's independent, never changes. So consequently, and it's a yes/no situation. Either it's defective or it's not. And at that point, we're like, okay, that makes it a Bernoulli. And then they tell us it has a box of 5 light bulbs. Okay, because that tells me the number of trials. So in this case, my probability is 0.3. My number of trials is 5. And by the way, trials is kind of anything that indicates that that we have a trial, probably going to be a binomial. So this is the binomial, and we should be writing that down every single time we do a problem. For ease and time, I'm not going to do that every time because these are all going to be binomials here. But in this case, I am going to make a sample list of what could happen. I could have 0 defects, I could have 1 defect, 2 defects, 3 defects, 4 defects, or I could have 5 defects. Now they asked me, what's the probability of having 0 defects? Well, specifically 0, and because I'm only circling one value, this is going to be a binomial PDF. So this will be a binom PDF with trials of 5. My x value is, or my number of defects is 0. The probability of defect is 0.3 raised to the 0. The probability of not having a defect, or Q, is 1 minus 0.3 or 0.7. So I probably would have just shown my work this way, and everybody's pretty happy with that. So here's how you do this on the calculator. All right, so on the calculator, and there's no good way because of the shadows. Well, so on the calculator, turning it on, and I go to the second vars, and scroll all the way down to binomial PDF, which happens to be letter A. And I see that it asked for my trials. In this case, we had 5 trials. The probability of a defect was 0.3. 0.3, and we wanted to know the likelihood that we'd have 0 defects. So I just plug in 0. And there it is, 0.16807. So it gives us all the work right there. It did this right here was the 5 factorial over 0 factorial over 5 minus 0 factorial. It did all of that work for you behind the scenes. So the next one, what's the probability of having 1 defective item? Once again, it's a binomial, 0.3, trials is 5, so I'm not going to rewrite that. We have 0, 1, 2, 3, 4, 5, and I'm only circling one number, so this makes this a binomial PDF. So my work shown is going to look like this. 5 choose 1. My probability of defect is 0.3. The probability of not defective is 0.7. And once again, I'll just go to the calculator, second vars, binomial, PDF, trials is 5, and I'm just changing my x value to 1. And I get 0.36015, and it's doing a ton of work behind the screens. What's the probability of having 2? So once again, 0, 1, 2, 3, 4, 5, and we know we have a fixed number of trials and a fixed probability. Fixed trials, fixed probability, and things are independent, binomial. So 5 choose 2, 0.3 to the second, 0.7 cubed, and once again, second vars, binomial, PDF, and I'm just going to change my x value to 2. hang out 0.3087. What's the probability of having 3 defective items? 5 choose 3. And once again, 0, 1, 2, 3, 4, 5. We're only circling one number. If you're only circling one number, it's a PDF. Second vars, binomial, PDF, X value happens to be 3. And we get 0.1323. I'm going to go ahead and skip down to the last one because we can see that 5 choose 4 is going to work the same way. If we had 5 choose 5, it also works the same way. It says, what's the probability of having 5 defective items? Once again, we have a fixed number of trials, which indicates to me that it's probably going to be a binomial. We know that the probability is 0.3 because they told us that previously. And this is going to be written just like this. And by the way, one thing I have not said is these exponents have to add up. So 4 plus 1 adds up to the 5. 3 plus 2 adds up to the number of trials. So 2 plus 3 has to add up to the number of trials. 5 plus 0 adds up to the number of trials. And even though this is the 0 power, I would go ahead and show it. I know technically, mathematically, that's 1, but please show it. So in this case, second vars, binomial, PDF, our X value is 0, and it works exactly the same way. All right, it works exactly the same way. Not sure what happened there, so I'm going to quickly rerun that. Second vars, possible that I have a typo. 5 trials, probability, oops. Trials is 5, p-value is 0.3, X value is 0. And it looks like that should have been looks like this is a typo, and it looks like that's incorrect. Okay, so that looks like that should be 0.16807. If that's the case, let me go back up, second vars, binomial, PDF. Oh, it wasn't X value, it was 5. I apologize. Because we were looking at X value. There we go, 0.00243. I chose the wrong X value. My error, which is one good reason to make the little number line and go, yep, that's what I'm looking for. All right. It asks, what's the standard deviation and expected number of defects in a box of 5 items? Well, expected value is NP. So 5 times 0.3 is 1.5. All right. And that, again, that's straight off the formula chart, NP. So on average, or in the long run, we'd expect to have 1.5 defective light bulbs. Please make sure you're using sentences at this point, right? I know we didn't require them earlier on, now we are. And then my formula is NPQ, or off the formula chart, it's going to look like this, NP times 1 minus P. So 5 times 0.3 times 0.7. And if you just show it this way, you're good to go. You don't even have to write the formula down, but just make sure that you're showing your plug-in, all right? And by the way, there's an advantage to not writing the formula. If you make a mistake writing the formula, they count off for it. So if you just plug in your numbers, you're in good shape. All right, so in this case, and here's the way I would do this, because you're working with square roots, I always want to point this out, helps out, is 5 times 0.3 times 0.7, and I get my answer. Once I have my answer, I use a little caret button right here, press that button, and I'll raise it to the half power. Okay, I find that raising it to the half power eliminates a lot of errors because sometimes things don't fit into the square root very well. So 1.0247 defective light bulbs. So this is completely PDFs, all right? And I'm going to continue with the same problem. So basically, but now we're going to talk about problems that are CDF. This PDF is pretty straightforward, all right? And our problem was, suppose that we have a defective item is 0.3, and we have a box of 5 light bulbs. So we still have our defect rate is 0.3, and our box is 5. So we still have trials of 5. So what is the probability of having no more than 3 defective? That means we're interested in these values. We could have 0 defects, 1 defect, 2 defects, 3 defects, okay? But we could not have 4 or 5 because they said no more than that. That's what we want. So we're looking for the probability that X is less than or equal to 3, where X is our number of defects. All right, well, technically we're needing to do the PDF of 0 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3. And here's what that looks like. There's the PDF of 1, 5 choose 0. PDF of 0 plus the PDF of 1 plus the PDF of 2 plus the PDF of 3. Now, the nice thing is we don't have to show it that way. We can do the lowest and the highest by bookends. And the calculator through the CDF function does the work for us very nicely. So here we go, second vars. And by the way, when you have this type of problem, first off, you need to tell me what it is. It's a binomial. And then I would make sure that I say, oh, it's a CDF, and it's a CDF of what? In this case, 3, all right? So it's a binomial CDF of 3. Trials, we need to write that down, is 5, and our probability is 0.3. So make sure we're writing down what type of binomial. Trials is 5, P is 3, and then what it is, what you're typing into the calculator. It'll help you out. So second vars, binomial, CDF, trials, 5, our probability, 0.3. And we wanted no more than 3 defects, so we're choosing 3. And we get 0.96922. And what they did is they added up the PDF of 0, 1, 2, and 3. So I added up those 4 values and got it for me. This is what I have to show for work shown. This would have work shown, and then you need to tell me trials is 5, probability is 3, and that it was a binomial. What's the probability of having at least 3? That means I want the probability that X is greater than or equal to 3, at least 3. So I want these values. Well, anytime it's an at least situation, it's a 1 minus. So this is going to be 1 minus the binomial CDF. All right, 1 minus the binomial CDF, but what am I subtracting out? I want 3, so I always go with the highest value I don't want. The highest value I don't want is 2, so 1 minus the binomial CDF. And I know you said, hey, why isn't it 3? It said they wanted 3, and it's like, yes, don't subtract out what you want, subtract out what you don't want. I want 3, 4, and 5, so I'm going to subtract out what I do not want, which is this. All right. So here's the way I can show my work. Technically, I want the PDF of 3 plus the PDF of 4 plus the PDF of 5. So there it is, the PDF of 3 plus the PDF of 4 plus the PDF of 5. Again, what if they'd asked for 20 items? Just take the lowest and the highest. So there's the PDF of 3. And right here, this is the PDF of 5. So on the calculator, 1 minus, second vars, binomial, CDF. The highest value I did not want was 2. And I get 0.16308. And there's my answer, which is essentially the PDF of 2 plus the PDF of 3, the PDF of 4, plus the PDF of 5. All right. So make sure when it's an at least, it's 1 minus the binomial CDF of the highest thing you don't want. So when it's at least, make sure it's the highest thing you don't want. All right. What's the probability of having 2 to 4 defective items? So that means I want these. So technically, it's the PDF of 2 plus the PDF of 3 plus the PDF of 4. And I can show that by saying this should have, wow, I actually have my work shown incorrectly. I didn't realize that. I should have said this is a PDF of 2 right here, and this is the, so this is incorrect. So this is incorrect. This should have been written like this. 5 choose 2, 0.3 squared times 0.7 cubed plus dot, 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 plus the highest one I wanted, which is 5, choose 4, 0.3 to the 4th, 0.7, 5 minus 4 is 1. So that's what I should have shown, because it's a PDF of 2 plus a PDF of 3 plus a PDF of 4. Now, how do I go about doing this? All right, on the calculator, this is a little bit of work. The highest thing I want is 4. So I'm going to do the binom CDF of 4 minus, be careful here, never ever subtract out what you want, subtract out the highest thing you don't want. Well, I wanted 2, the highest thing I don't want is 1. So binom CDF of 4 minus the binom CDF of 1. So this is going to look like this. Second vars, binom CDF. The highest thing I wanted was a 4 minus second vars, binom CDF, and the highest thing I didn't want was 1. And I get 0.46935. All right. And once again, if I did a binomial PDF of 2 plus the binom PDF of 3 plus the binom PDF of 4, I would have gotten that answer. All right. So I'm going to do that real quickly one more time. Second vars, binom CDF. The highest thing I wanted was a 4 minus second vars. Oops. So second vars, got to start over. Highest thing I wanted was a 4 minus second vars, binom CDF of the highest thing I did not want, which was 1. Never subtract out what you want. Always subtract out what you don't want. Start with the highest thing you want and then subtract out what you do not want. All right. And so this should have said binom CDF of 1. It should not have said binom CDF of 2. That should say binom CDF of 1. Okay, thank you.